G'day everyone, welcome to Lubrication Explained. Today's interview is with Greg Livingston. He's the Chief Innovation Officer at Fluidtech, and we ponder the question, can oil last forever? Hey Greg, how you doing? Greg is the Chief Innovation Officer at Fluidtech, and so I guess maybe as an opening question, uh, what is a Chief Innovation Officer, and what does that mean? Your day at Fluidtech looks like?
All right. Well, thanks so much, Ray. And it's awesome to be here. My title actually sounds really cool, but a lot of people are like, what does that mean? So Chief Innovation Officer, I am the bridge between our scientists and our R&D team and our sales team. From my perspective, it's like a dream job because we're understanding. I have to spend time at our customers, understanding what their needs are, and I'm spending time with our research team and our scientists, figuring out next gen, what is possible with next gen technologies, and then trying to kind of mesh them together.
Yeah, that's really interesting. I think it's such a cool thing that Fluidtech has carved out that specific niche, because I think in a lot of companies, the job role that you're describing would have been taken up by the marketing department, acting as the sort of like the part of the feedback loop from the customer back into the research teams. And sometimes, the marketing skill set and the R&D skill set, and they don't mesh together all that well. So I think carving it out as a very specific job role, to me, that makes a lot of sense.
It's worked really well within Fluidtech.
Yeah.
So, and I love my job description. So it's awesome.
Yeah. Okay, cool. And if you wouldn't mind just telling us a little bit about your background. So, I mean, what you did maybe before you came to Fluidtech, and what's your background in the kind of lubricants industry?
Well, so like many other people that have ended up in our space, this wasn't really their dream in college to get into the world of industrial lubricants, and same with mine. So when I graduated from college in '92, came out of university with a business degree and thought, oh man, I know so much about business. I'm going to do really well, and got a job at an oil reclamation company. And then within the first maybe hour or two of work, realized that literally I knew nothing about business or industry. So that confidence that I had coming out of university did not last very long. But I was very fortunate in my very early on in my career when I recognized I really don't know what I'm doing. I hired a consultant who just retired as a lube engineer for a major oil company. And he was a brilliant man, didn't want to retire yet. And so basically I got to hang out with him. And at the time, this was in Western Canada, and we drove all over Western Canada, 12 hours a day. I would just pepper him with questions. And actually, that's kind of what my whole career has been like ever since. I've tried to surround myself with really, really smart people and remain curious and ask them tons of questions all the time. And over time, some of their knowledge kind of seeps on me. So, but before Fluidtech, I've worked in for coming up on 30 years now, I've been involved in industrial lubricants, either analyzing them, filtering them, or ultimately helping maintain them. And it's what I've been doing for my whole career, and certainly the last 14 years at Fluidtech.
That's awesome. And such a good piece of advice too, for people coming into the industry, just to be sort of curious and always asking questions. I think in many ways more important now than ever, because there seems to be so much experience that's leaving our industry or about to leave our industry too, right? And so there's so much knowledge that's disappearing, and so kind of incumbent on us to gather as much of it as possible.
Yes. Yeah, you're exactly right.
Just wanted to talk about Fluidtech in general. You guys have this concept which you call "Fill for Life," right? So I think that's a sort of like a trademark, like a branding kind of thing. And but you also have products like Infinity Oil and things like that. So there's this concept that I think you guys are getting to, which is basically that your oil should last for life, right? Or forever. So maybe if you could help explain that and what you guys mean when you say, forever or infinity or whatever, like you want to talk about. Is that,
Yeah.
the life of the machine? Is it the life of the oil? Is it truly forever? Where are you guys trying to get to with that?
So I think the first thing to realize is that this is not actually a product we're selling.
Yeah.
This is really more of a mindset. The concept is that if you properly maintain an oil, you should be able to expect that oil to last for a long time. And if your objective is the oil to last as long as the piece of equipment that it's lubricating, then that's a pretty significant milestone. And so that's our objective. And so forever, it's not like longer than I will live or longer than, it's basically how will it last as long as the component that it's actually. And so we're moving a little bit into this. If you look at some industries, well, essentially we have some oils that are designed for long life, like transmission oils or oils in the lubricant in your ceiling fan or something. We have lubricants that are designed for a very, very long time. And if you look at the wind turbine space, we are really both OEMs and customers are pushing. Can we get these oils to last as long as the actual gearbox will last? And we're getting close to that, actually. There are like gearboxes in wind turbine applications. The average age is about 10 years. And oils now are getting up to being able to last that long. So we're seeing this certainly in some spaces.
Yeah, and actually, I mean, in the wind turbine industry, it seems like this sort of next generation of oils, some of the time they're being warranted for 10 years, right? So it's almost a guarantee from the oil company that it will last the lifetime of the gearbox.
Exactly right. Yeah, that's a really, really significant thing. It's funny. I think this is probably not a concept that is, I imagine, being really pushed by oil manufacturers. And it's not necessarily because this is contrary to their volume-based business model. I mean, a lot of oil companies actually go to great lengths to try to upgrade their customers to synthetic fluids and long life oils. But I think from a technical perspective, formulating a new oil, all of the variables, and then trying to formulate, an in-service oil and replenish additives that are in in-service oil. Now you have all sorts of other variables. And so I think from an oil company's perspective, maybe it's a little lower risk or a little simpler to try to upgrade to a, next gen high performing product rather than try to mess around with in-service oils. And so I do think that this is technically feasible, but this is going to be pushed by OEMs and end users. And eventually I think oil companies are going to recognize that this is what our customers are looking for and need, and will therefore respond.
Yeah. It's so interesting that the wind turbine space is kind of ahead of the curve when it comes to this. And I wonder how much of that is driven by the fact that it's just so damn hard to change the oil on a wind turbine, right? Like it's just inconvenient. Changing the oil on a diesel engine, I know that it's very different application, but is a relatively easy thing to do, right? Or changing the oil on a gearbox on like a standard enclosed gear, that is a relatively easy thing to do because it's just there, right? You just go, you change the oil versus, especially with some of the offshore turbines. I mean, that's not a trivial exercise to change out the gear oil on one of those things. And
Exactly.
so when you were saying maybe this is a change that's driven by the end users, just the inconvenience of changing your wind turbine gear oil, I can imagine drives customers to some demanding more from the oil.
Yeah, it's exactly right. Yep.
One of the things I think is interesting when you guys talk about that is we're starting to get into that idea that lubricants are maybe an asset more than they are a consumable, right? So I think there's been sort of a view in the industry for a very long time that lubricants are a little bit like fuel in some ways, right? You purchase them, you use them, and then you have to deal with the waste. Um, Now, when we're talking about fuel for life or fuel for the lifetime of the equipment, now we're having to treat the oil with a lot more care, and maybe think of it as being part of the machine rather than something that we've put into the machine and we're taking out. So, could you please maybe like expand a bit on that philosophy and what it takes for us to well, two things. First of all, change our mindset around how we treat oils and lubricants, but also what are some of the steps that we'll need to take as well to treat them as an asset.
Oh, that's a good question. I think, for years, the best oil you could buy is the cheapest oil. And the cousin to that methodology is the best oil analysis package you could get is a free one that comes from your oil supplier. But I think slowly, as companies are evolving, they're recognizing that actually lubricants can play a competitive advantage for your business. And if you have the ability to actually have really high performing oils, it can make your machines run better, and in manufacturing abilities, lower your manufacturing plants, it can lower your manufacturing costs. It can actually be truly a competitive advantage. So I think as companies shift to, thinking about their oils rather than the cheapest possible product, but buying the best possible oil you can for that application, then doing everything you can to maintain that oil in the best condition possible. That's actually not only cost effective, a competitive advantage for your business.
Yeah, it's so interesting. Sorry if you don't mind me jumping in here, because I think in general, in my experience in the industry anyway, that kind of idea is reasonably well accepted by the engineers on the ground, like the idea of total cost of ownership and all this kind of stuff. Where we often run into problems, I feel, is actually in procurement departments who are, because if you think of yourself as a, let's say a procurement specialist, most of the companies that you deal with in lubricant procurement, they're often also fuel companies, right? So a lot of the bigger oil companies are lubricant and fuel providers. And when you're dealing with them in the fuel space, that is a commodity play, right? So it's all about dollars per liter and, can I adjust my logistics to make sure that at the fourth decimal place I'm better than my competition. And so those same people are selling you lubricants, and they sort of often take that same approach. So in many ways, I think it's almost a problem of our industry's own making that we've sold lubricants the same way that we sell fuels, and that's turned it into a commodity game.
It's a really interesting perspective. I would agree with that. Yeah.
Anyway, it's a sort of a pet peeve of mine, but maybe if we also get into, because there is a mindset change that obviously has to happen, right? To start treating our lubricants as an asset, but also we're going to need new tools as well. Like you said, as an example, not just choosing the cheapest oil analysis program. So what are the kinds of things that FluidTech, when you start working with a new customer and you want them to start taking them on that journey, what are some of the tools that you would recommend to them?
So the most important thing I think to start off with is oil analysis and really understanding the condition of the in-service oil. And this is something that throughout the whole process is really, critical aspect. The next two things are really simply, if you're able to take the bad stuff out of the oil and then put the good stuff back in the oil, then you're going to have an oil that can last for a really long time. So just conceptually, it's somewhat simple. To actually put that into practice is a little more complex. But in terms of taking the bad stuff out of the oil, there's all sorts of technologies that have been around for a long time that address dirt and water. So we know that these foreign contaminants that can get in the fluid, you can remove those. I think one of the big changes that we've seen is absorptive absorptive filters that have the ability to remove dissolve degradation products in the oil. Now, these filters actually, we've been using absorbent type filters for years. If you look at like diatomaceous earth has been treating transformer oils for the last 50 or 60 years. And it does a great job at removing all, oxidation products and all of these dissolved components, but it also strips all the additives out. And I think one of the major advancements that we've had in the last 15 years in the filtration business is the ability to remove degradation products in an in-service oil while preserving and not stripping out additive components. And so I think that's been a pretty big advancement that helps this whole filter life concept. And then the second part is the additive replenishment component of it. And so that is something that, again, requires a lot of upfront analysis. But, it's not, companies are already doing additive replenishment. They may call it bleed and feed, or, they're sweetening the oil. But in many cases, you're adding something to the in-service oil to improve a property. And anytime you ever do that, I think you have to take some care to make sure that whatever you're adding is fully compatible with the in-service oil, and there's not going to be any adverse reactions. And really, that is the same thing that goes with additive replenishment. If you can do all the testing up front and simulate the process up front, you can identify if there's either incompatibilities or anti-synergies that are happening with the different additive components. And so you can, the key to additive replenishment, it's not inventing some new additive that works with every oil. It's really just weeding out the bad apples and treating the oils that are in good condition and are suitable to be refortified and while they're in service.
Okay. Oh man, I've got so many questions come out of that. So the first one, maybe just a comment actually, was I love that idea of using a concept that everyone's familiar with to get them over the hurdle, right? So you're saying, hey, you already do this. You do bleed and feed. That is additive replenishment. There's no, realistically, there's no difference. I love that idea because it's the same as when we talked with Mika Patula about from Fluid Intelligence, the idea of saying, okay, to procurement departments, lubrication as a service, it kind of seems scary, but you have Netflix at home, right? That's entertainment as a service. You're familiar with it. We're just applying it to a different business case. So I really like that idea. I'll have to use that. The one thing I was going to quickly ask about though is the selective filtration technology. You said that's kind of a new thing that we've, let's say in the last 10 to 15 years, have been able to execute on in the industry. To a lot of people, I think that seems a little bit like magic, right? Because most people think of a physical filter and it can only select based on particle size. So what are some of the kinds of technologies that allow you to separate out, quote unquote, the bad stuff versus the good stuff in the oil?
Yeah, so there's a couple that are in use right now. The most common is the use of ion exchange resins that are actually not performing any exchange of ions, but this media is being used as an absorptive site for degradation products. And you can design the media to attract certain components of the oil, say acidic components or polar components. And so you can design the media to very selectively attract certain components of the oil. And so this is what works really well for turbine compressor type applications using ion exchange type medias that are just targeting degradation products and the bad stuff in the oil. And again, ion exchange medias have been used for a long time, say in phosphate esters and unadditized oils, but applying them to the world of mineral based oils is actually a relatively new concept.
Yeah. Okay.
The other technology that has been used a little bit is putting some coagulant or some kind of an agglomerator in the product that allows degradation products, even submicron degradation products, to agglomerate together. And then you can filter that chemistry out of the oil. So that's a relatively new concept that I think is being worked on right now as well.
Yeah. Okay. One thing sort of tried to explain to people is that, uh, at a molecular level or whatever you want to call it, you sort of only have a couple of tools in your toolbox, right? You can either filter based on physical size, or you have to use charge, right? Like
Yes.
there's no real magic here. Like
Yeah.
you know,
It's a very good point.
everything has to interact based on, charge, right? Like that's all we have really. But you can accomplish that in a bunch of different ways. So, it's not magic. There is some science to it.
Well put.
Now, the other question I wanted to ask you on that was, when we talk about additive replenishment, and you talked about the idea of, we're not just gung ho and saying, hey, I have some additives in my toolkit. I can add that into any lubricant I want. There's a certain amount of testing and compatibility study that is going to go on prior to additive replenishment. How do you guys, you could argue FluidTech operates across, a broad spectrum of industries, and you obviously work with a bunch of different companies who have different oil suppliers, right? So you may be applying additive replenishment to any number of different oils. So how do you guys, as an example, I know there's an sort of an antioxidant replenishment product that you guys have. How are you making sure that your product can work in like the vast majority of cases? Is it just that most of the antioxidant systems used by the major oil companies, they're not obviously identical, but they're similar enough that you can be very confident that your product will be compatible with them?
So compatibility. So there's two perspectives on this. There is compatibility, and then there's additive synergies.
Yeah.
And there's actually not that many say turbine oils in the world that are totally compatible.
Yeah.
You may have some that have that are using, say, an acidic rust inhibitor versus a basic rust inhibitor, and you combine those two, and you could create some kind of precipitate. But for the most part, there's good compatibility. The big challenge we see is really in antioxidant synergy. And sometimes if we add antioxidant to an in-service oil, you may see the RPBOT, or the oxidative stability of the oil, actually go down. And so additive synergy becomes a very, very key part of this. And to our approach, we have several different antioxidant technologies. So we would apply to different formulations. And it may not be the exact molecule, the exact antioxidant molecule the oil was originally formulated with. However, we can verify with upfront testing that it is not only compatible, but it's also synergistic with that additive. And so that's really our goal. It's not to necessarily reverse engineer every formulation and be using the exact same molecules that the oil was formulated with. It's the same as it's basically to provide antioxidant technology that works really well, that will extend the life of the product without any adverse effects.
Yeah, right. And maybe just to expand a little bit on that, because we talk a lot about antioxidants, I think primarily because there's so much focus on it with turbine oils, right? Like, people using the ruler test to monitor aminics and phenolics. But across, some of the different applications, let's say, hydraulics and gear oils and things like that, people are probably more accustomed to maybe monitoring their anti-wear. Like a lot of the time, that's an easier one to do because you just watch your zinc and phosphorus, and it sort of slowly depletes, or at least that's how people generally think of it, even if they have sulfur-based EP EP additive packages, but we don't generally test for sulfur in a lot of ICP results. So, are you guys coming up with, I think you're probably most well known for replenishment of antioxidants, but is FluidTech looking across all sort of like the different additive chemistries, if you like, to provide solutions for those as well?
Absolutely. So I would say we started with the easiest one first. Antioxidants. The nice thing about antioxidants is that we're not dealing with, polar constituents that are basically fighting for a space on the metal components. And once you start dealing with surface active additive components, now you really have to make sure there's a good balance so that your EP and your anywhere additives are all functioning the way they're supposed to. And so that becomes a little more complex when you start dealing with surface active additives. We have been working for the last several years on replenishing anywhere agents in hydraulic oils. And I'll tell you, one of the biggest challenges with this is that actually most people don't really understand how much their antioxidant or their anywhere package is left. So as you say, they may be looking at actually, zinc or phosphorus or calcium, but we're just looking at elements in elemental spectroscopy. We're not looking at molecules. So getting people to think more about the ZDDP additive, that molecule, what are the antioxidant capabilities left of that product? So in other words, what does a ruler say the life of that additive is? It's also an antioxidant. And so the ruler test works really well for that. And then the other test is actually infrared analysis and actually looking at the molecules rather than the elements. And that can give you a pretty good idea of the health of the anywhere package. That being said, though, once you start moving into the world of surface active additives and dealing more with tribological tests, then some of the costs go up as well because, tribology tests are very, very expensive.
Yeah, yeah. Well, that's interesting, and it sort of brings us back to one of our earlier points, which is really that one of the tools that we're going to have to make a lot more use of is oil analysis. And in many ways, the sort of like the sophistication of our oil analysis really needs to be elevated a little bit, right? Because some of the tests that you were talking about, I mean, infrared and ICP and ruler, they're all available, and a lot of companies are already doing them on a regular basis. It's just not necessarily how they're interpreting the data in that way.
That's such a good point. Exactly. Infrared is a perfect example. It's a cheap test to run that most people are already running it, and they get an oxidation number or nitration number.
Yep.
There's something that's spit out of the infrared machine that is giving some value that people are using, rather than actually people looking at the spectra and identifying actual changes in these molecules.
Yeah, that's really
It's just more sophisticated interpretation of the results, really.
Yeah. Okay. Maybe if we could pivot a little bit to sort of the industry in general, and maybe how you sort of see this concept growing. I think I spoke a little bit about this again with Mika in a previous interview about the idea that there are some other companies that I feel are sort of starting to coalesce around this idea that we should think of lubricants as being an asset. SKF, I think, is a really interesting one because not an oil company, but with their, I think it was an acquisition, I think, of Recon Oil, right? That sort of puts them into that space. So it feels like there are sort of more players moving in. How do you guys see the business landscape? Is this something, so far I haven't really seen this concept taken on by any of the oil companies. It's a lot of the service providers that seem to be moving into this space. So, you spoke a little bit about the fact that it's not really in the oil company's interest, but how do you see this playing out over the next, let's say 10 to 15 years?
Great question. So I think if you look at the overall trends in the industry, if you look at mineral oils, if anything, the growth of mineral oils is flat. If optimistically is flat. If you look at the growth of synthetic oils, year after year, it's outpacing the growth of mineral-based stocks. And so I think we're already seeing some big changes in the types of lubricants that are being used. In 15 years from now, there's going to be a much, much stronger focus on using renewable base stocks.
Mhm.
And I think, it's just STLE have in their trends report, they talked about this, the use of um, sustainable and environmentally degradable oils is absolutely going to supplant,
Mm.
what we're currently using today as mineral oils. So the oil companies, there's already a lot of changes that they're experiencing. 57% of the lubricant space is the automotive, passenger car motor oils. We're seeing huge disruptions in that space. And so I think the oil companies are undergoing some huge changes right now. And so I think this is a concept that will be driven by end users and OEMs because it is technically possible. Certainly, putting technologies to remove the bad stuff, that's actually pretty well accepted. But refortifying in-service oils, we've shown that it can be done. Our oldest case study is from 2012. This 4 7FA gas turbines and a couple steam turbines have been running for coming up on 10 years. With the oil now is 18 years old. Hundreds of are coming up on 200,000 operating hours. So it absolutely can be done. So I think that end users are going to be pushing oil companies, and it's a matter of time. We're already seeing tremendous changes in oil companies, and I think it's a matter of time before they adopt this process as well.
Yeah. And interesting that you bring up the idea of, the synthetic growth being outpacing mineral growth by a considerable margin, because that sort of suggests that total industry demand globally is actually increasing. But, obviously with synthetics, the volumes are so much smaller than mineral oils. Um, so the other thing about synthetics is that uh, there's a lot more variety in the chemistries than there is with mineral oils, right? Like mineral oils, that there's some differences between group 1 and 3, and we've obviously experienced that with turbine varnish. But with the synthetics, an ester, a PAO, an AN, a PAG, like it might as well be
Totally
the
different.
species.
Yeah.
So how do you guys envision sort of applying a lot of the concepts and the technologies that you guys have developed across some of those different chemistries? Is it going to require different products for, let's say, for example, different base oil strategies, or is it the case that you can sort of approach it as a one size fits all?
Not at all. So the one of the major advantages of using these synthesized molecules is that you can have a really tailored molecule for a specific application, and so we're going to need to have tailored products for these various different base stocks as well. All of it, I think, plays into the concept of pill for life oils. If you're moving to more oxidatively robust lubricants or base stocks, then clearly you're going to be able to develop or maintain an oil much longer. So I think the increased use of all these synthetics plays perfectly into this the concept of filter life oils.
Yeah, yeah. And even just from the mindset point of view, I think just the expense that people have to outlay, or that companies have to outlay for these products, means that you're going to take a little bit more care with them too, right? So from that, going back to our original discussion about mindset, as people start to transition to synthetics, hopefully that means that they up their game on, condition monitoring and oil analysis, because it just makes sense from an expenses standpoint to do so.
Exactly right. Yes.
Yeah.
Yeah. So there's no question. I think people are going to be already people are considering lubricants as an asset. And this is a trend that we are seeing more and more and more every year. And with environmental pressures and companies aiming to be more sustainable, then looking at trying to, extend the life of the non-renewable resources like oil makes perfect sense, especially if you can do it in a way that it may, in some cases, even improve the reliability of your equipment.
Hmm.
So it ticks all the boxes, and it happens to be less expensive than buying new oil. So there's not too many environmentally sustainable initiatives that you can do that actually will also save your company money and lower risks. So this is one where I think it ticks many boxes.
Well, that seems like a fantastic place to end. Greg, thank you so much for your time, and I'm sure we'll see you soon.
Pleasure. Thanks so much, Ray.